Hello, welcome back to Proximity Math. I'm gonna go over the 2006 Aime Ii number 12. Okay, we have an equilateral triangle ABC inscribed in a circle of radius 2. Right here is a circle of radius 2. So first of all, okay, anyway, if you extend the AB through B to D such that AD equals 13 and AC through C so that AE equals 11, then through D, draw a line parallel to AE, and through E, draw a line parallel to AE. So what that does is make this parallelogram with their intersection being F. So let G be the point on the circle which is collinear with A and F and distinct from A. So now we have to draw a line that goes through A and F because it's collinear with A and F and it's not A. And there, okay. G is the point on the circle. Okay, so G is this point basically. Given that the area of triangle CBG is okay, blah blah blah, we have to basically find the area of triangle CBG. So the area of triangle CBG is over here as this triangle. Sorry. The triangle that seems very hard to find apparently because G, we have very little information on G. Actually, no specific information on G. So, well, since it's a parallelogram, we have this side being 11 and this side also 13. And now let's look at the circle. We have the fact that it's equilateral, the triangle ABC, and it's inscribed in the circle. Well, what if you look at the arcs? Arc AB, BC, and AC are all 120 degrees, obviously, because their inscribed arcs are 60 degrees. And notice arcs AC, so arcs CAB, arc CAB. The measure of it is the AC plus AB, the measure of those arcs, which is 60 plus 60 is 120 degrees. Which means an inscribed arc subtending this arc, an inscribed angle, CGB is, which is subtending this arc, would have measure 120 degrees. Sorry. This arc has measure 240 degrees because the angles, they're 60 degrees each. So this arc 120 degrees. This arc is also 120. So CAB will be 240. And the angle CGB would be half of that, which is 120. So okay, now we have an angle which is shared with the parallelogram, actually two of them. And if you look closer at the subtended arcs, this angle of the parallel, which is part of the parallelogram, angle DAF, this would be subtend arc BG, and the angle over here also subtends that arc. Over here we have an angle which is also subtended. Also, it's the angle which subtends the same arc as the angle over here, arc CG. Okay. Now, well, what do we have here? we see that these two, if you look at triangle CBG, angle G is 120 degrees, which means these two angles, C and B, add up to 60 degrees. And we have their sum right here, which means the angle of the parallelogram, angle A, is 60 degrees. And from that, we can find out the other angles easily. This would be 180 degrees minus that, 120 degrees. This is also 120 degrees. And this is 60 degrees again. All right. Now we can use law of cosines to find a length we don't know. At least let's start with that. So law of cosines gives us 11 squared. Sorry. Squared minus, and cosine of 120 degrees is negative 1/2. So that would become a positive, and the 2 and the 1/2 would cancel out. So this would be just 11 times 13, because it's minus 2ab cosine of theta. It would become plus ab instead. This is equal to, we have 121 and 169. So over here we have 143. These two sum to 290, right? Yeah, 290. Wait a second. Yeah, 290. Okay, and then 290 and 143. That becomes 433. So 290. Yeah, okay. It's 433, which means the square of side AF by law of cosines is 433, giving AF to be the square root of that. And can we simplify this? This is not divisible by 3. It's not divisible by... Well, we can leave it like that for now, even if it does have any simplifications. Okay, now we have the length of side AF. We can label the angles in the parallelogram. This angle, this angle. Okay. Like angle AFD is the same as angle EAF by parallel or alternate interior angles. But it's really a really basic fact about parallelograms. Okay. Anyway, if you look closer, we immediately notice triangle CBG has the same exact angles as triangle ADF and also triangle AEF for that matter, because both of these have one of the 1 dash and 2 dash angles. See, this angle and this angle, we have one over here and one over here in this triangle. Okay, which means they're obviously similar. And we also know for a fact that this angle is 120 degrees and this angle is also 120 degrees. Okay, so since it's asking us for the area of CBG, we can use similarity. Well, once we find the area of this, do you have any side lengths you can compute to be similar? Okay, the circle is of radius 2. So this is 2. We can draw a 3, 4, 5, sorry, 30, 60, 90 right triangle. 2, 1. Okay, this is going to be 2 root 3. Or you can use law of cosines if you're bored. Okay, 2 root 3. So AB is going to be 2 root 3 if the radius is 2. So side CB, BC is the long side of both of these triangles. I mean, CB is the long side, which is 2 root 3, since it's equilateral. And then AF is going to be right here. So now that we have a ratio of sides, the area of triangle CBG area of triangle CBG would be the ratio of these sides squared. So 2 root 3 is the long side of the smaller triangle CBG, and then the long one is the bigger triangle has a long side of root 433. That's a ratio, and then it's squared because it's areas times now the area of this triangle. You can use lost signs. 11. Sorry, and then the sine of 120 degrees, which is root 3 over 2. Okay, now this gives us our final expression. We can evaluate to be, okay, the top is going to be 12 and then over 433. I'm going to group the root 3 over 2 and 1/2. And then the 143. Does 433 is it divisible by 13 or 11? Well, if you subtract 13, you get 420, which is not divisible by 13, so it's not. Its alternating sums do not equal 7. Okay, so meaning this is relatively prime to this, so we can simplify to get 429. 429 over 3 over 433. And our final answer is the sum of these numbers, which is 429 and 3, okay, 432, so 865. 436. Okay, and that's our final answer. Thanks for watching. I hope you enjoy and this helped you. See you next time.